Okay, so for this slide, he helped us to understand how we can compute total entropy and epidemic uncertainty on our fine-tuned data set. So first step, we average the prediction. We averaging the token probability from our student model across the 10 dropout passes, and we compute total entropy and measure the uncertainty of the average prediction, and then we compute the expected entropy by averaging the uncertainty inside each individual dropout passes. Then we subtract expected entropy from total entropy to get our mutual information, which is epidemic uncertainty about our data set. So for our experimental pipeline, we select Queen 2.572b instruct as our teacher model, and we feed this model with 12,000 math problem, and we make our teacher model to generate 5 reasoning trajectory for each problem. So this will give us 60,000 total candidate trajectory. And we choose the Queen 2.53b as our student model. And we use student model to score each trajectory with 10 Monte Carlo dropout passes. And then we use total entropy as our baseline and use epidemic uncertainty as our proposed data set. And then we then use those data to fine-tune our student model. So for our evaluation setup, we use a MAP 500 and GSM 8K as our benchmark, and then we use this benchmark to evaluate our model to compare baseline and epidemic selection, and we use the accuracy other one as our accuracy metric, and we extract first box as our final answer. So this is a paragraph of overall accuracy comparison. So we can see that the results manifest there's not really different accuracy between the baseline model and epidemic model. So the baseline model on Math 500 is about 46.2, and on epidemic model is about 46.4. And on our GSM 8K is about 79.3 on baseline model and 79.45 on epidemic model. So I also make the graph for analyze the Math 500 in difficulty level. So we can see the epidemic model, he increased about 3.4% on level 2 of its accuracy, and also increased 2.4 accuracy on level 4 and increased about 2.3 accuracy on level 1. And they have the same on level 3, but for level 5, which is hardest problem, the epidemic model did not do well. So my conclusion and takeaway here is the epidemic uncertainty slightly outperform well over total entropy selection, and the improvement was positive on both Math 500 and GSM 8K. Even though the effect size was small. So what does this mean? So this means Bayesian uncertainty is a promising direction for trajectory selection and is useful for identifying informative recent data. But even though this result is not strong showing our proposed idea in this project, so I think for the future world, I should working on how we can have stronger answer normalization and equivalent checking on our model. And also, I want to improve uncertainty preservation during our model distillation. So this is my presentation. Thank you for watching.